Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the project you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Lineage. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distribution, they've got that covered too with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances. Go to dataengineeringpodcast.com/linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And understanding how your customers are using your product is critical for businesses of any size. To make it easier for startups to focus on delivering useful features, Segment offers a flexible and reliable data infrastructure for your customer analytics and custom events. You only need to maintain one integration to instrument your code and get a future-proof way to send data to over 250 services with the flip of a switch. Not only does it free up your engineers' time, it lets your business users decide what data they want where. Go to dataengineeringpodcast.com/segmentio today to sign up for their startup plan and get $25,000 in Segment credits and $1 million in free software for marketing and analytics companies like AWS, Google, and Intercom. On top of that, you'll get access to Analytics Academy for the educational resources you need to become an expert in data analytics for measuring product market fit. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to dataengineeringpodcast.com/conferences to learn more and take advantage of our partner discounts when you register. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, read the show notes, and get in touch. And please help other people find the show by leaving a review on iTunes and telling your friends and coworkers. Your host is Tobias Macy, and today I'm interviewing Joe Doliner about Pachyderm, a platform that lets you deploy and manage multi-stage, language-agnostic data pipelines while maintaining complete reproducibility and provenance. So, Joe, could you start by introducing yourself?
Yeah, sure. My name's Joe Doliner. It's great to be here talking to you today, Tobias. I am the founder and CEO of Pachyderm, and I started life as a software engineer. The first company I ever worked at was RethinkDB, and that's basically the only other company I've worked at besides a little while at Airbnb between.
And so, do you remember how you first got involved in the area of data management?
Yeah, absolutely. I mean, I have always been interested in data infrastructure tools. So RethinkDB was an open source database, and I knew coming out of college that I wanted to work on these types of data management, data analysis, data manipulation tools. So I joined that company right out of college and got to cut my teeth doing like open source software development and data infrastructure and things like that. Absolutely fell in love with it. And then after I left RethinkDB, I got really interested in big data. You know, RethinkDB is more of a like transactional database. You use it as like the back end of your website. And so I wanted to learn what the world of like data science and data analysis and everything looked like. And so I started sort of hacking on Pachyderm in my spare time. It was actually sort of started because I wanted to use the Hadoop platform to analyze some chess games. I'm a big chess fan. And the system was just really, really kludgy, and it was all based on Java, which I didn't like that much. So I sort of started hacking on what an alternative to this might be. And along the way, I spent some time working at Airbnb. And so I got a chance to see, you know, what their Hadoop infrastructure looked like and what the challenges were there. And so doing this concurrently with hacking on my own stuff, it sort of eventually turned into the platform that became Pachyderm. And, you know, then we managed to get funding as a company, and the company sort of took off from there.
And so I actually had Dan Whitenack on to talk about Pachyderm way back in episode 1 about 2 years ago. But I'm wondering if you can talk a bit about what has happened in those 2 years, both in terms of the platform itself and the company and just the overall environment of big data and data analytics that you're fitting your platform into.
Yeah, absolutely. The core mission of the company hasn't really changed much. You know, when I was working at Airbnb, I saw a lot of gaps in the data infrastructure that existed in that day and age. The biggest one I saw was sort of an absence of the ability to track any sort of provenance or lineage of the data. And the way that this really came up for us at Airbnb was we, had this massive pipeline of data analysis tasks that had been written by a bunch of different data scientists. And it was really, really challenging to keep all of these green at the same time because, everybody's modifying them and they're all sort of working independently, and someone makes a change that's incompatible with the ones downstream, and then the whole thing just cascades red all the way down. And so we would have important tasks like our fraud models that would just sort of start coming out blank when something went wrong. And when that happened, I'd be going in to debug it and sort of trying to figure out like, all right, where along the way did this break? And I didn't have any way to ask the system, like, give me the full lineage of this data, because it looks wrong or something like that. And so that hasn't really changed. What has changed is sort of the rest of the platform maturing around us. So when you first talked to Dan, we were probably about 6 months into using Kubernetes. And that was because Kubernetes 1.0 had been released probably 5 months ago. And so we were sort of trying to figure out what we could do on this platform and what sort of stuff it could provide. And now that's a lot more clear. And there's been a lot of features that have been figured out in Kubernetes that we've been able to just sort of like pass along to our users. We've also figured out a lot how to integrate with various machine learning packages that exist. So Kubeflow didn't exist at the time when you talked to Dan or when Kubernetes first came out, but it does now, and it gives you a very, very good way to sort of deploy a machine learning pipeline on Kubernetes, which by extension gives you a good way to deploy these machine learning tasks in Pachyderm. And this is actually very complementary with Pachyderm because Pachyderm basically takes the data right up to the point where it gets into the machine learning model. So, any type of sophisticated machine learning model is going to have a lot of steps in it that are cleaning the data, getting it into the right format, joining it with the right data you need to train stuff. And then the actual, training process happens inside of Kubeflow. And then that comes back out into Pachyderm. And then we start doing the inference steps and the checking how good this machine learning model is and stuff like that. And that all happens within Pachyderm as well.
And I know that there are a number of other features of Kubernetes itself that have occurred in those past 2 years, including things like stateful sets. So I'm wondering, what are some of the other primitives of the platform that have come along that have simplified or obviated certain parts of the Pachyderm code base itself?
Stateful sets are definitely one of them because we're not a stateless service. Pachyderm, in fact, is all about storing state because it's like for storing large amounts of data. The majority of the data is actually stored in object storage. And so that worked before stateful sets. But we also rely on etcd as the sort of metadata and consensus system for Pachyderm. And so having a stateful set up to manage etcd is really nice and manages things really well. Another thing that's been really, really big for our customers in particular is GPU support. So, you can now in Kubernetes, and this has been true for a while, you can, submit a resource request to say that this pod needs this much memory, it needs this much CPU, and you can also have it ask for GPUs. And what that'll do is it'll tell the scheduler that this needs to be scheduled on a machine that has a GPU, and it needs to be given a GPU and have that available to it during processing. And so this is really nice when you want to run these high-powered machine learning tasks that train a lot faster on a GPU. See, other things in Kubernetes that we've been relying a lot on the ingress features for some of the cloud stuff that we're building now. We're in the process of rolling out our cloud offering for Pachyderm. And the fact that Kubernetes can do, a lot of sophisticated ingress things with load balancers, and you can build authentication right into those, has been really, really useful for us.
And so, as you mentioned, Kubeflow has come along, and that's, as you said, complementary to the capabilities of Pachyderm. But I'm wondering if you can just briefly talk about what are the sort of main pieces of Pachyderm itself. I know that there's the Pachyderm file system for supporting versioning. There's the Pachyderm pipeline system. And I'm wondering if you can talk a bit more about any sort of additional complementary aspects of the overall big data ecosystem of things like Airflow or Kafka or, various other sort of big data pieces that fit together nicely with Pachyderm or that Pachyderm sort of supplants in terms of the overall workflow of somebody who's building an analytics pipeline on the Pachyderm platform.
Yeah, absolutely. So at a very high level, the two pieces that you just touched on, the Pachyderm file system and the Pachyderm pipeline system, are basically all of Pachyderm. Everything that we have, we think of as in one of those two camps. The file system, like you mentioned, is responsible for providing version control for your big data. So if for those of you who haven't heard the first episode where Dan talked about it, it's semantics very similar to Git. You've got, commits, you've got repos, you've got branches, but it can store massive amounts of data, and it's storing it in cloud storage. So it's storing it in like S3 or GCS or something like that. The Pachyderm file system is also the thing that's responsible for enforcing the provenance constraints. So it's got basically this constraint solver built into it where you say, here's a repo that contains images, and here's a repo that contains tags on those images, and then here's a branch that is associated with those two branches, meaning that it contains computations that have been done using those images and those tags on those images. And the Pachyderm pipeline system uses this API to then implement a machine learning pipeline that takes these tags and these images and trains a classifier based on those. But in theory, something else can use that. And other people do implement their own things on top of this and basically use the provenance system without using our containerized execution system. And you can insert SQL queries in there, you can insert all sorts of things in there. The pipeline system is what's responsible for the scheduling of these tasks. And so that's, uses Kubernetes to say, I want this branch to be materialized that contains machine learning models trained on the images that come in here and the tags that come in here. And the pipeline system knows, okay, when a new commit comes in, I need to spin up these pods. I need them to have GPUs. I need them to, have these containers in there so that they have TensorFlow. And then it runs all the code and it slurps up all the data and makes sure, the data gets into the pod and then the data gets out of the pod. And ultimately you get your results. And because of the provenance system, your results will always be linked to the inputs that created them. So there's no way to short circuit this. It's not like a system where you need to sort of like, when you check in your results, you also check in a manifest of where it came from. It's basically, hard enforced by the system. To give you an idea of some of the sort of new things and how this plays into other data systems, we recently released this feature called Spouts. And these are sort of like a pipeline in that they schedule a pod on Kubernetes. What's different about them is that rather than pipelines which normally take inputs, process that data, and produce outputs, these just stay up all the time and they produce outputs. So it's like a spout of data coming into your system. And so this is really, really useful for subscribing to a Kafka topic, for example. And this sort of allows you to have like a very convenient shim between Pachyderm and any other system that you can subscribe to, because it's a container. You can put whatever code, whatever libraries you want in there. So, you can very easily have something that subscribes to a feed on Twitter and gets new tweets coming in, and those will just show up in your Pachyderm file system. And then downstream of that, you can have all sorts of sophisticated pipelines and stuff that are processing those tweets, that are training models on those tweets, stuff like that.
Yeah, and I think that that's definitely one great differentiating factor between the Hadoop platform that you're working to sort of replace, where it's entirely batch-oriented, and there are sort of streaming capabilities that have been bolted onto it, but having it built into Pachyderm as a first-class feature, I think, is definitely useful, given that there is, particularly in the past couple of years, a lot more of a push to doing real-time and streaming analytics.
Yeah, absolutely. And we this was one of the sort of earliest features that we conceived of, because we have very sophisticated streaming capabilities, but it's not like when you're making a Pachyderm pipeline, you choose like, okay, this is going to be a batch pipeline and this is going to be a streaming pipeline. There's really no difference between the two. And the reason that is, and the reason that we can do that, is the underlying version control system. So because we can always say, all right, this is, this data has this hash, it's part of this commit, it hasn't changed since the last commit, we processed it then, we got a successful result, here's the result, again, identified by a hash, so we know that it corresponds to the same code, the same data and everything. We just get to reuse that result. And so really the reason that it's a streaming system is that we've got this pretty sophisticated computation deduplication system in the background that just whenever it goes to compute something, it tries to figure out if it's already computed it. And if it has, it just uses that result. And so this is often a bit of a magic moment for people when they first start using Pachyderm, is that they put in a bunch of data, they churn through it. It takes a little while because it's an expensive computation. And then they add a little bit more data and it happens super quickly. And we actually get people coming into our user channel asking, like, why did this happen so quickly? I think something's broken. It didn't process it. We're like, no, the system just figured out that it didn't need to reprocess all of that data. And so you got a result really quickly because there actually wasn't much to do.
Yeah, and when I was reading through the documentation, I was definitely impressed by the deduplication and data hashing capabilities that you have in the file system and how that supports the incrementality of computation so that, as you said, you don't have to do a complete rebuild of an entire batch job. You can just work on the data that's new since the last time you ran something.
That was one of the things that I was most excited about having before I even really started working on Pachyderm, because I spent so much time waiting for things to recompute. And I think probably anybody who's tried to do a decent sized data project has experienced this, where like you write out all of your code, you run it on all of your data, and then you find that there's this like one or two like files that have like some slightly different format that crash the whole thing. And so then you fix your code and try to get it to run, and you can't get it to run on just the stuff that it failed on. And so you have to sit there and wait for 2 hours to see if it works on these like two files. And then if it doesn't, you have to do that again. And this was even worse at Airbnb, because we had like so many things depending on each other and we had so much data there that basically the granularity that we had was running stuff once a day, because the pipelines would run every single night. And so if things were broken, then we basically write some new code, we commit it, and then we come in the next morning and hope that it worked. And if it didn't, then we do the same thing the next night.
Yeah, that's definitely a quick way to build a lot of frustration and burnout on a data team.
Mm-hmm. Yeah, that's really the biggest reason that I wanted to do this company and this open source project, is just that I felt like data teams in general were in a state where they could be a lot more productive if the tools looked a lot better. It reminded me a lot, and still does to a certain extent, of what making websites looked like before the LAMP stack, in that, people had all these CGI scripts, there were all these things that you could sort of cobble together, but there wasn't just this like well-known good platform that you could just get out of the box and build a website in like a weekend in your garage or something like that. And then once that platform existed and people started to congeal around it and the tooling started to explode, you got all of these like explosion of websites and people were able to make all of this cool stuff. And I feel like that still hasn't quite happened yet for data science and data engineering, but we're getting a lot closer to it.
And that's definitely something that I'd like to talk through in the context of Pachyderm, is how the sort of collaboration between data scientists and data engineers and the sort of breakdown of responsibilities and workflow happens within data teams, both when it's just one data scientist doing everything, or when you're working at a medium to large organization where you actually have that separation of roles and just the overall process of going from conception to delivery of a data project.
Yeah, absolutely. So one of the first most important things to say about this, because it's often sort of a misconception that people have that throws them off a lot at the beginning, is that Pachyderm is not trying to be a replacement for Git or GitHub or any of these other code version control and collaboration tools. We're version controlling different things. And so when people are successfully collaborating on Pachyderm, normally what this looks like is you have your code in GitHub or GitLab, somewhere stored in version control, and you have a repo. I like to have it all in one repo, but you can have it across multiple repos. You have a repo that has your analysis code that can be compiled into Docker containers, and then also has your pipeline manifests that explain how to deploy this onto a Pachyderm cluster. And then from there, you set up a CI pipeline that basically redeploys these these pipelines when commits come in so that you can basically like merge into master and you can have a CI/CD process on top of this. And then from that, where you start to leverage the Pachyderm features is the fact that when you want to have a branch that people are working on that's a sort of experimental thing, you can have your CI/CD process deploy that into separate branches and separate pipelines in Pachyderm that can still share all of the underlying data. So you don't need to make a copy of the data. It's still all version controlled and deduped, but you can have, these two pipelines running concurrently and you can see, okay, this one's running like this, this one's succeeding, whereas this one's failing. So we want to move the one that's succeeding, and this one is performing this much better based on like these metrics pipelines that we've put on at the end. And you can basically have a collaborative process around this because the tools enable it. It's a very open-ended tool, similar to Git. Like, people have a million different branching strategies on Git. People use mono repos. People use like small micro repos for their projects. And Pachyderm isn't particularly more prescriptive than Git in that regard. So we see people using this in a bunch of different ways, but the core like underlying concept is that you can collaborate because the system is tracking your versions for you. And so you sort of always know which way is up, because you can always just ask the system, what's the history of this data? What's the lineage, meaning like, take me back to how this data was produced, versus history is take me back to what it looked like, yesterday, a year ago, etc. And you can do things like bisects. You can say like, this looks bad now, it looked good a week ago. Where in between did it change?
And one of the challenges inherent in Pachyderm is just understanding some of the primitives of things like Docker and Kubernetes. And so I'm wondering what you have found to be some of the common challenges or points of confusion or stumbling blocks for people who are coming into this project and trying to get up and running with it. Because even just trying to define a Docker file can oftentimes be a nightmare in and of itself.
Yeah, so that's definitely one of them, is just understanding, this idea that Docker is like a machine that you're sort of setting up every single time, but it's not really a VM. And sometimes like the details of your machine poke up into it because it's the same Linux kernel, everything like that. That's definitely one of the challenges. I think that's one that people normally get past, at least these days. That used to be a lot more of a challenge maybe 3 years ago. But I think that just both the learning materials about Docker and Docker files and stuff, and just the sort of communal knowledge of that have really started to take hold. So, most people at this point, if you're working at a decent sized company, even if you don't know Docker, somebody there does and will be happy to sit you down and explain, like, here's how you make a Docker file, here's how you build things. I don't think the same can really be said for Kubernetes yet. And in some ways, I think that makes sense because Kubernetes is newer and it's also a more specific tool and a more complicated tool. So definitely the biggest stumbling block for people getting started with Pachyderm is just getting Kubernetes set up. And, we help people with that all the time as much as we can, but we're actually not super Kubernetes experts either. We understand how to use it and we understand how to deploy it in our system and stuff like that. But people who want to deploy it on-prem, people who want to deploy it in sort of weird settings and stuff like that, we don't always know what to tell them about how to get Kubernetes to work. I think that those are the biggest two. The other one that is kind of interesting is getting like the underlying storage set up. So to run Pachyderm, you need access to an object store and you need some sort of a persistent volume for etcd to run on. And on AWS or GCE or Azure, this is all pretty well known, and we have a deploy assistant that will basically just spit out a manifest that you can give to it that will set up all of these things for you on Kubernetes. But the variety of object stores that people want to run against seems to be growing in our experience. And so there's all of these sort of slightly off the beaten path ones like Ceph and SwiftStack and ECS and things like that. And each one of those is a little bit of a new adventure to get the system set up on. And then it's also a bit of a new adventure for us because while they all ostensibly support the same S3 API, there are little subtle differences in how they support that S3 API that occasionally trip our system up. And so we've been doing a decent amount of work recently on just like trying to cover all of these different subtle differences between them and get it to work on all of these object stores.
And another thing that can often be challenging when working with cloud oriented workflows is trying to figure out what the local dev story looks like. So I'm curious what the general approach is, or at least what your general approach is for trying to do local experimentation and iteration on some code, or maybe trying to pull in some subset of the data in the Pachyderm file system for getting things ready to go before you ship it off to production.
Yeah, absolutely. I mean, I'll say sort of upfront that this is one of the parts of Pachyderm that I'm least satisfied with how it is right now. There's, I think, a lot of work to be done on it. And I think that there's a decent amount of work in just Docker land in general to make this really good. The sort of anti-pattern that you get into that really sucks is that your development loop looks like write some code, build a Docker container, push that Docker container to Docker Hub, redeploy a pipeline that points to that container, which then pulls down the container and runs it. And then you see, that's possibly taken, 10 minutes or so. And then you get some results back on what you need to change. And it's like, oh, this Python code doesn't run. Like you're referencing a variable that doesn't exist. And then you try it again. And you can't just run it on your local machine because you don't have the data accessible to you. What I do when I'm developing pipelines on Pachyderm that works pretty well is I do everything entirely on the same Docker host. So I have Minikube running, and that's just running on Docker on my local machine. And then when I build my image, it just builds on my local Docker host. And then when I run it, it's the image is right there. So I don't need to push it anywhere. I don't need to pull it anywhere because it's right there. And that leads to a pretty quick development loop. The other thing that you can do that can be pretty effective is Pachyderm supports a fuse mount for your file system. So you can just do pack control mount, and a directory will show up that has all of the data in that's available within your distributed file system within PFS. And it's kind of cool because you like ls this directory and you're like, oh shoot, here's like a file that's terabytes in size. And of course, this is only working because it's not actually on your file system. And then you can run your code against this fuse bound, and you can run with actual data and see how things are going to work. The challenge with this is that, one, it doesn't create the Kubernetes environment around it. So if you want to have like a secret available to you in Kubernetes such that you can access some outside service, then you need to sort of mock that up. And sometimes the time spent mocking it is like not really canceling out the time that you're saving by not just pushing this into the Kubernetes cluster. The other thing is that Pachyderm gives you this pretty nice way to describe how data gets split up, which is just using glob patterns, which are the things that you're like, if you're familiar with LSing around on a command line, when you do like ls star, that star is a glob character for glob patterns. And this in Pachyderm is how you define that, like, you can process all of these things in parallel and it parallelizes it. But when you just mount data in, it's not respecting that in any way. So we have some work to do in terms of the local development story for Pachyderm for sure. It's right now, it's good enough that people can get things done. And the real reason when things really get nice is when you have some code that you sort of want to be running in production and you want to be able to rely on this just running every single night. And then Pachyderm is great at just like running every single night, keeping it going and letting you know when there's an error.
And going back to the idea of data provenance and data lineage, you've mentioned that some of the way that it's tracked is through these versioning capabilities of the file system, but I'm wondering if you can just dig deeper into the underlying way that it's represented as far as tracking it both from source to delivery, and how that actually is exposed when you're trying to trace back from the end result all the way back to where the data came from and what's happened to it along the way.
Yeah, absolutely. So the level that we track provenance at is the commit level. And the sort of first problem that you have to solve if you want to track provenance is you want to store a reference to some data that you know isn't going to change. Right? Because if I tell you like this machine learning model was created using all of the images in this image directory, and then I go and add 10 new images to that image directory, well, then that doesn't tell you anything anymore, right? Because you don't know what was actually used to create the model. You just know where that data happened to be stored at the time when it was used. So commits allow us to have this immutable snapshot of what data looked like at a certain point in time. from there, we link these commits together. So if you've got pipelines in Pachyderm, then the input to those pipelines is data commits, and the output from those pipelines is also data commits. And the relationship between these commits is the provenance relationship. And so any commit in Pachyderm basically has this metadata attached to it that just is all of the commits that it is provenant on. And you can, inspect these commits using the command line, using our API, using the web interface, and it'll just show you a list of these commits. And then of course you can track those commits up and look at what's in those commits. And so the actual, the structure of this is a pretty standard directed acyclic graph structure from computer science. Now, something that's sort of a cool aspect of the provenance system is that we actually track provenance at another level, which is the branch level. And this doesn't quite mean the same thing as commit provenance. Commit provenance is this sort of immutable snapshot that tells you here's where this data came from. The provenance on branches basically describes how your data is flowing at the time. So if a branch is provenant on another branch, then that means that every time you get a commit to the upstream branch, you also get a commit to the downstream branch. And that downstream commit is the results of processing the upstream commit, which means, of course, these commits are going to be linked via provenance as well.
What are some of the other advanced capabilities of Pachyderm that you think are worth calling out that are often overlooked or underutilized?
I think I wouldn't say it's necessarily underutilized, but it's definitely not something that people immediately associate with it, but that gets a lot of use, which is our sort of cron functionality. And that's the ability to have a pipeline that isn't triggered by putting data in the top and getting data out the bottom, but rather it's triggered just on a cadence. And so people use this a lot of times as a way to, do something every hour, do something every night. They use it to scrape things. They use it to push things and stuff like that. I think that is definitely, that's one of those features that's not actually super sexy. It's just super useful. Let's see. I think that the fact that you can sort of expose a lot of the various Kubernetes underlying Kubernetes things is something that hasn't been fully explored. People are sort of finding new things to do with that every single day. So you can, in Pachyderm, you can attach to pipelines any sort of random modifications to your pods. And so this can be useful for assigning affinities. It can be useful for, declaring resources that you need. But there's always these new things being added to Kubernetes that are really, really useful. And those sort of just naturally propagate up into Pachyderm.
And for the file system and for interacting with other source systems, does Pachyderm support things like the S3 select API or being able to run pushdowns on the different data sources for trying to optimize for speed and latency and reducing the amount of data that actually needs to be transferred over the wire?
So it does. We can sort of select individual pieces of it if that's what you're talking about. I actually don't know what the select API does specifically.
So my understanding is that S3 recently added an API where for certain file types you can actually run a select query so that rather than just pulling down a blob, it can actually index into the data itself and understand what's contained within it so that you don't have to return the entire object.
We'll probably have some trouble leveraging this because Pachyderm is designed to work on a bunch of different object stores. And so we're pretty reluctant to implement anything that's only going to work on S3. One thing that this did remind me of, though, that's a cool new feature that we just added, and so it hasn't gotten anywhere near enough love because it is only very recently released, is we now support an S3 API on top of PFS. And so if you have applications that are used to sort of writing data into S3 as their data lake, then you can just swap in Pachyderm and it speaks the S3 API and you can put things in there and those will turn into files in PFS that are committed and stuff like that. And underneath the hood, this is all still going into S3. So it's going to have much the same, storage characteristics that you are used to in terms of costs and everything like that. But you're going to get this version control and the ability to run pipelines on top of it in addition.
That's definitely really cool, being able to just transparently put Pachyderm in there so that the end user doesn't even have to be aware of it, but at the same time, they're getting some of that added benefit of provenance and deduplication that Pachyderm supports.
Yeah, this is also how we support data tools that are used to reading stuff out of S3. So for example, this is how we support Spark, is that Spark, can be told like, read this data out of S3, perform this Spark operation on it, and then write it back into this other place in S3. And now because we speak the S3 API, that can just be Pachyderm under the hood. And you're now have provenance on your Spark operations.
And so, in terms of the provenance, I know that because you're versioning the containers that are executing as part of the pipeline, that is an added piece of information that goes into it as far as this is the data that was there when we started it, this is the code that actually executed, and then this was the output. But for external systems, do you have any means of tracking the actual operations that were performed to enrich the metadata associated with the provenance?
Yeah, so those can basically use the same system we use, which is that, so we track the information about all of the code that ran and the Docker container and everything like that. But we actually just use that by piggybacking on PFS's provenance system, because we just add that as a commit. So every job has what we call a spec commit that specifies how the job is supposed to be run. And that includes the code and the Docker container and everything like that. And so outside systems are basically just expected to, whatever you can serialize this information as, just put it in a commit. And then, that's just, in essence, it considered as an input into the pipeline. Like, it's really not, in terms of the provenance tracking in the storage system, any different than any other input. It's just that this one happens to define the code that's running in the computation.
And so earlier you were saying how Pachyderm, because it is so flexible, the ways that people are using it is sort of up to everyone's imagination. And so I'm curious what you have seen as far as being the most interesting or innovative or unexpected ways that people have been leveraging the Pachyderm platform.
Man, let's see. I mean, so there's things that are interesting because the end results are interesting. So I think that, a lot of the image processing and machine learning things that I've been seeing trained on that are the most interesting to me. They're not really like, sort of cute little hacks in the system or like interesting abuses of the system. Some of the really interesting things that people do in terms of like, things that I never thought anyone would do in terms of the system are sort of calling out to other Pachyderm APIs from within the pipeline. So, you can have a pipeline that as part of its operation, like creates another pipeline or does something like that. And this is something that we don't officially recommend that people do, because we haven't really thought about it enough and think there might be some weird things, but we've seen people do some really like cool things with it and stuff. So, we don't police this in any way or anything like that. That's sort of the great thing about open source software is, we're not going to stop you from doing stuff. It's yours. You can do whatever you want with it, but it's not something that we had sort of officially thought about as a use for it.
We'll let you aim your foot gun on whichever foot you want.
Right, exactly. That's a very important principle to us, is that, we don't want to give you like foot guns in disguise. We don't want to trick people into using foot guns, but we also, it's, if you can't shoot your foot off with a system, you also can't do anything clever with it. And this is, true of all of the sort of Unix ecosystem and things like that. Is like, you can shoot your foot off with it, but you also, in those abuses, can find really cool, useful things to do. And so we feel like we have to be open to, people doing that with Pachyderm, because we have gotten a lot of our best, features and our best understanding did originally come from people abusing the system.
And so a few months ago, you announced that you had raised a Series A round of funding. And I know that with most venture capital, that usually comes with some strings attached where they're hoping for some measure of hypergrowth. And so I'm curious how you're approaching that stage of growing and scaling the Pachyderm platform and business.
Yeah, absolutely. And this is always, I think, has an extra wrinkle to it when you're talking about an open source company, because, there have been some, I think, notable cases where an open source company has sort of like raised money and like stopped really ascribing to the open source roots that got them where they were. And it's gone pretty badly for the community. We feel like we are very aligned with our investors, both in terms of what long-term Pachyderm needs to do to be successful. And so we're not as much focused on like, okay, we need to have this amount of revenue by this day. We need by, this, not this day, but like this quarter, this year, or something like that. We need to have this number of users. And we're much more focused on what does it take to build a long-term sustainable open source project and a company that is also long-term sustainable around that. And so we are much less focused on any particular revenue goal in the short term and much more focused on basically making Pachyderm into the platform that we've always believed that it could be, and making it into something that's like a ubiquitous tool for sort of the underlying data infrastructure, particularly on top of containers. But we feel as if containers are kind of going to be the underlying like cloud infrastructure for everything. And so the data infrastructure that goes on top of them is really going to be the de facto infrastructure for everybody. It does, of course, investors invest because they ultimately want to see a return. And so we need to make money off of Pachyderm. And that comes from both support contracts, our enterprise product, and we're currently rolling out our cloud offering, which we think is going to, over time, become basically the vast majority of our revenue. And so far, we don't feel as if any of these things are at odds with each other, not maligned. It's just a little bit, tricky to get all the puzzle pieces to fit together to make sure that we're staying true to the open source community and, everybody who's used and contributed to this product up until this point, and also keeping the company around it going, because the reality is the open source project probably isn't going to survive without the company contributing to it.
And so in terms of your overall experience of building and maintaining and scaling the Pachyderm project and business, what have you found to be some of the most challenging or useful or unexpected lessons that you've learned?
Definitely the most useful lesson I think I've learned is just to really listen to your users and see how they're using the product and try to go from there. I came into this with a whole bunch of ideas of what I thought a cool data infrastructure system would look like and what I thought was going to be important to people. And I wouldn't say that I was wrong about everything, but I was surprised how much I didn't know. It wasn't even so much that the things I knew were wrong, just that there were these like massive things that I hadn't even thought about. I mean, Provenance is kind of a great example, actually. We initially implemented Provenance as a sort of internal thing that we were like, okay, we need to do this to track and keep things consistent and everything like that, and be able to sort of see this stuff. And then it started to get more and more important for people, and people wanted it more and more. And then there started to be like things like the GDPR that actually legislated Provenance into the system and stuff like that. Or at least legislated them on companies that they had to be able to like give people an explanation for machine learning made decisions and things like that. And so all of these things would have been easily missed if we hadn't really been listening and sort of going back every single day and seeing like, okay, how are people using this? How are people failing to use this? Things like that. The other thing I think that I've learned and been rewarded with is both taking risks on new open source projects. Like Docker was pretty new when we started using it, and Kubernetes was like brand new when we first started using it. There were a decent amount of internal discussions about like, do we want to use a platform this new? And like, even at the beginning, there were a lot of discussions of like, why are you guys building this system rather than just building, a Dockerized thing on top of Hadoop, or like a provenance tracking thing for Hadoop? And it took a lot of conviction to just say, no, we're going to build something new. We're going to like take a stab at doing this our way and see what happens. And ultimately, I feel like we've been very rewarded for that. But it took a lot to be confident in doing that.
And what are some of the limitations or edge cases of Pachyderm, and when is it the wrong choice?
So it's definitely the wrong choice when what you're doing is sort of like a very well-established data pattern that there's very good tools for. I think the best example of this is SQL. We have a lot of people ask like, what, imagine I want to do Redshift style like data warehouse queries against Pachyderm. What's the best way to do that? And right now, the best answer to that is to just use Redshift, because it's really good at that. Or, any of the various options. There's like BigQuery, there's Hive, there's Presto, and things like that. You can sort of start to integrate those things into Pachyderm. Like people will build Pachyderm pipelines that basically just orchestrate Redshift pipelines or BigQuery pipelines or things like that. But SQL is not something that we're able to beat the things that just do SQL at, because there's a lot there, and it's not the most interesting challenge to us right now. Pachyderm really tends to do well in kind of like the everything else data case. When people are thinking like, I've got, these genetics files, and while, there's some pretty good toolkits for analyzing these like on a single machine or something like that, there isn't really like the distributed genetics pipeline tool or anything like that. And so for those, because Pachyderm is a super generic system and you could just package those tools up into Docker containers and run them stuff, it's very, very nice for that. It gives you some structure to these tools that otherwise you'd just be like firing off with scripts ad hoc on like random EC2 boxes, things like that.
And looking forward, what do you have planned for the future of Pachyderm?
So the biggest sort of change in terms of what the company offers is rolling out of our cloud offering, which is called PackHub. And if you sort of think of everything in open source Pachyderm as Git, and that, it enables collaboration on data science, things like that, then PackHub is kind of like GitHub for data science. And so it's basically an online site where you can go and you have your account, and it contains, your data repositories and your pipelines that process those repositories, and you can fork other people's pipelines, and you can pull in other people's repositories and things like that. It's a way for people to actually collaborate on live running big data pipelines. That's the thing that we're most excited about in terms of what's different. There's also, of course, tons and tons of work to be done on the core open source project. So there's a lot of upgrades to the storage layer that are going to make it a lot more sophisticated and a lot faster, that I'm very, very excited about. And there are a lot of sort of new pipeline features that are coming out. I mean, Spouts was one of the first ones of those. We're also sort of implementing more sophisticated join support so that you can join two data sets together, and the ability to have more sophisticated pipelines that do like loops and conditional branching and things like that.
And so for anybody who wants to follow along with you and the work that you're doing at Pachyderm, I'll have you add your preferred contact information to the show notes. And as a final question, I'd just like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, I mean, that's sort of the biggest gap that I see is the one that I'm trying to fill, because I felt like that's why I wanted to do this company and what I felt like the opportunity was. But, I would basically describe that as the absence of a really good set of tools that are just sort of prescriptive in how you're supposed to do these things. There are ways to do all of the things that Pachyderm allows you to do. You can write some form of version control on top of object storage. You can like use Git repos in theory and stuff like that. But there's nothing that really ties it all together and gets out of your way and lets you focus on the actual data science that you're really good at. And again, I'll go back to the analogy of the LAMP stack, wherein, it used to be to build a website, like you needed somebody who was an expert on actually implementing databases, because none of them worked that well for you. You needed somebody who like understood how to run all of these servers and all of this stuff. And then once you get this stack that people can congeal around, that's just a very well-known, well-trodden path, the documentation starts to get really good because there's so many people using it, then we can stop thinking about that stuff and do all of the interesting stuff that allows, like build, Facebooks and eBays and things like that. And so we still feel that hasn't really happened with data science, and that the way to get that to happen is to focus on the infrastructural layer that's needed to tie everything together, and do it in a generic enough way that people can use all of their different tools on top of it. So, I think that the LAMP stack worked really well because you could do all sorts of things that you wanted to do. And, the PHP part became very generic, and people started swapping Python in there, and people started swapping Perl in there, everything like that. We have that same level of flexibility with our Docker container-centric workloads, but we provide the same underlying like storage and orchestration primitives that we think are basically what people need to get stuff done.
Well, I appreciate you taking the time today to join me and discuss the work that you're doing on Pachyderm and how it has grown and evolved in the past couple of years. So I definitely think that it's a great project. It's one that I've been keeping track of for a long time now, and I hope to be able to use it for my own purposes soon. So thank you for all of that, and I hope you enjoy the rest of your day.
Thank you, Tobias. It was great to be here.